As part of your prediction for this week, I asked you to predict a situation where we had a string, which is what we have here, connected to a mass. And I asked you about the tension in the string. And so as a video today, what we're going to look at is this tension right here. I'm using a force sensor, like we did in the last lab when we looked at Newton's third law. And we are going to measure the force in this string using the force sensor. And so right now, this is stationary. And one thing you need to write down is I have a 1 kilogram cart right here. And over at the far end, over here, you can see that I have a 200 gram hanging mass. And maybe you can see it or maybe you can't, but just a 200 gram hanging mass, which is of course 0.2 kilograms. So you'll need to write down that information because you will need that for doing your calculations for this part of the lab. Again, I'm going to make a graph of force versus time for you, and we're going to see what the tension is in different parts. But before we get to that, I just want you to think about the prediction that you made for this week's lab for this scenario right here. And I want you to think about the tension in the string. And I asked you as part of the prediction, if this tension in the string right now is larger, smaller, or the same as when the cart is accelerating because of the hanging mass over there. And so what do you think? Is it bigger now? Is it smaller now? Or is it the same when I have it accelerating? So hopefully you have something in mind. And what I'm going to do is I'm going to hit collect on here. We're going to measure the tension in the string just for a few seconds so that we can get a good average measurement on it. And then I'm going to let it accelerate, and we're going to measure the force on the sensor as it accelerates as well. So here we go. So here's a few seconds of measuring the force, and then here's accelerating. All right, so let me zoom in here on our graph. It's hard to see right here. But because we were pulling on the sensor, we get a negative graph here. And all I'm going to do is just highlight our graph, and then I'm going to hit the stat button so we can see what the statistics are for this section. So we have a mean force for this section of about negative 1.96 newtons, which should not be a surprise to you because we had a hanging mass of 0.2 kilograms, and if we multiply that by approximately 10 for the value of the acceleration due to gravity, then we get a force of about 2 newtons. So that tension should not be a surprise. But if you look right here, this is when our mass was actually accelerating. Now, the first thing you might notice about this section right here is that it's bouncing up and down an awful lot. And the reason is that we jerked on the sensor. And whenever we jerk on the sensor, it rings almost like a bell. When you ring a bell, it vibrates back and forth. That's why this is vibrating back and forth here. But if I go ahead and hit stat, what it does is it averages out all of that up and down motion, and it just gives us a value. And if you look at the value that we get for the mean, it's about negative 1.6 newtons, which actually is lower than our value over here. Here we're about negative 2, here we're about negative 1.6. And so we went from about 2 newtons in our tension here to down to about 1.6 newtons here. And then of course when our string hit the ground, or when our mass hit the ground, our string went limp. And so we got a string tension up here of basically about 0, which is exactly what we would expect. So now the question is for you, did you get the prediction right that the string tension goes down when it's accelerating, or did you not? If you did, then you shouldn't have any problem in your conclusion section for this lab explaining to me why the tension went down. If you got the prediction wrong, you're going to need to go ahead and figure out why you got it wrong. And I would suggest that you look at the force diagram of the hanging mass. Draw the force diagram for the hanging mass when it is stationary and then again draw the force diagram for the hanging mass when it is accelerating. And hopefully something will become apparent to you, and you'll be able to explain to me why the tension went down. But anyways, I hope you enjoyed this demonstration, and I'll look forward to seeing your lab report.